Hello guys, you're welcome to the ninth video in this series. Now in this video we're going to be talking about statics and constants in Rust. Now what are statics? Static variables are simply variables that actually has what is called a static lifetime, which means they're going to be available throughout the duration of the program. And so what does static look like in Rust, and why do we need to use static? So static is a variable that can be used in multiple places, so which means it can cut across functions and threads and things like that. Now normally statics is regarded as bad practice, because most people don't actually like to use static in the programs because it doesn't it usually indicates bad program design. But sometimes there are reasons why you might want to use static variables in your program. For example, you probably have like a global variable that you want to be storing some sort of global state and it's never going to change in your program. So static variables are a great way to do that, and that is actually supported in Rust. So another thing we're going to be taking a look at in this video is going to be constants. And what are constants? Constants are simply values that will never change in the program. You create the value once and it's never going to change. It's always going to be there and the value is always going to be the same, and that's why it's a constant variable. So we're going to take a look at constants first because there's not really a lot to talk about with constants. I'm going to be showing you a couple of things about static, so I'd like to get over the constant variables first. So what are constants? Constants is declared with the const keyword, so I could say something like pi 3.1415, I guess. Now this is not going to work because variables in Rust, constants and static variables cannot be inferred by the compiler, so you have to put a type annotation on it. So as you can see, it says missing type for const. So here I'm going to say this is an F32 because this can actually fit into the F32 variable, and this is as simple as you are going to get for defining constants in Rust. That's all you need to know about constants. Constants are variables that cannot change. Like I said, you cannot say pi equals 30. It's not going to work. You're going to get an error that says invalid left hand side of assignment. It says cannot assign to this expression because you cannot actually do that. Alright, so that's the reason why constants are useful. They're generally used to store constants, things that do not change. And so if you wanted to use it in your program, just create a constant with const and then the value. Make sure you put a type annotation because if you don't do that, it's not going to work. And then you put the value instantly. That's how you create constants in Rust. Now you might be wondering the difference between constants, because here I could do something like let a equals 20. Now you might be wondering, so let's say this is I32 instead, I32, and then I'm going to put 20 here too. Now you might be wondering the difference between this and this. Now this is an immutable variable, this is not constant, and the reason for this is I can actually declare or define this variable later. So I could do something like if true a equals 20 and else a equals 30, and this is gonna work. This is not constant. Okay, let me see just to make sure this actually works. All right, so I could print line, so pi there, a is so if I want to print a, then I could do a like that. And if I run the program, just to show you that I'm not lying, you can see the program runs and it says a is 20. Why is a 20? Because this is actually true. All right, so if I declare another variable and I say b equals 30, and I say if b is less than 100, I guess, or is greater than 100, just to make sure that the value actually changes. Now you can see that even though you can see now a is now 30 because b is not greater than 100, b is just 30. Now you can see that a is not actually a constant. So a constant, as soon as you create a constant, you have to provide a value for the constant. But immutable variables in Rust are only immutable once you have assigned a value to that particular variable. So you can see I can still do something like this, and this is a valid way to write code in Rust and it's still gonna work. Alright, so keep that in mind, and that is the difference between constants and immutable variables in Rust. Right, so now that we have that out of the way, let's talk about statics. Statics are the more interesting parts of the program. Now, like I said, some people consider statics as a bad practice. I don't necessarily think that that's true, simply because I'm an Android developer and I've written some code that sometimes you have to interface with Android. And trust me, telling Java to store some of those pointers and variables for a program is basically you're gonna have to write a bunch of boilerplate that sometimes are not worth it. So sometimes you have to use statics in your program, or global variables as it's called in C, C++. So it's really cool that I can actually write static variables in Rust and I can use that in my Android application. So that's why I'm going to be showing you some cool things about statics here in this video. So in order to create a static variable, it's similar to how you create constants. So you say static, then the name of the variable. So I could say, for example, counter. I say it's i32 and I say 0. Now this static variable is immutable by default. Okay, now whatever is under it is just saying that it's never used, dead code and all. So you can use it just as you use any variable. So you could say the static value is now counter, and you should get once I have fixed this, you should get 0. Get out of my face. Crap. What is this? I need to change my color scheme back to what it was. I guess I'm gonna do that later. So right here you can see that the static value is this, and if I try to run this program using cargo run, you're gonna get this. The static value is 0, just as you would expect. Now, just to give you a point, static variables in Rust by default does not actually have any issue, because this variable is immutable. The reason it's immutable is because, well, if you want to declare mutable variables in Rust, you have to put the mute keyword somewhere to show that the variable can actually be modified. Now, it's safe to use these static variables anyway, because it's going to work similarly to how you use constant variables. So you have to keep that in mind. Now, what if I wanted to create a static variable so that I can actually modify the variable as I want? So for example, here I have this counter variable and I want to increment the counter, but I want it to be static because I want to use it in another function, but I don't want to pass this variable to that function. So what I can do is put a mute keyword here, and as you can see, now every time I want to use this variable, it's going to be crying at me and it's going to tell me that this is actually unsafe. It's unsafe because use of mutable static is unsafe and it requires blah 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 whatever cry. So all you gotta do is, of course, do the unsafe thing and put an unsafe block around the variable, and you can use it just as before. Now I have to tell you that you have to be careful when you're using mutable static variables, because like they said, it can cause data races, one thread accessing the variable and the other thread trying to mutate the variable, and bad shit like that can actually happen, and they're gonna make your program probably crash. So you have to keep that in mind. Now also, one other thing I want to tell you is that static variables can only be initialized with constant data. So for example, you can see here 0 is constant, alright? I cannot put something like an if. I don't think I can actually do this. Okay, but I'm gonna try. Excuse me. Let's see. So I don't think I can actually do this. Let's see. Oh, this doesn't look like an issue. Let's try this and see. Okay, I can actually do this. That's interesting, but the expression definitely is going to resolve to true anyway, so maybe that's why the compiler isn't complaining. But if I change this to a string and I try to use string from, this is not gonna work. So this is what I was trying to show you. So you can see calls in statics are limited to constant functions, tuple structs, and tuple variants. So basically, you cannot call a function or things like that to initialize a static variable. This is not gonna work. So in this case, you might be wondering, how do I store a static variable how do I store a static variable? How do I initialize a static variable with something that is not constant? Like for example, I want to create a string and I want to make it static. So for example, I want to do something like app name. All right, it's a valid thing to do. So I wanted to store the app name as, let's just say, my app or whatever. Now this is not going to work, as you might have known. What is this? What is this? Anyway, let's see. What is this? Name. Right. So like I said, this is not gonna work because it's gonna say calls static or whatever. So how can we make this work? Well, the way to make this work is to put this in an option of a string. I guess this is not where I want to put it. Option of a string, and probably set it to none, then call a function to initialize it. Or let's see if I can set it to sum and then put that inside of there. Right. So this actually works, I believe. Let me check. Okay, so I have to use the debug trait for. Right. This is an option, so I have to unwrap it to make sure that that actually works. And we're back to the error we had earlier. It says cannot move out of static items, so I probably need a reference. What is this? Okay, I'm going to say as ref to make sure that I don't move out of that. But this is still an error because it says calls and statics are not limited to blah blah blah. So I cannot do that. So what I can do here is set this as none, then possibly have an init function that allows me to say my app name is equal to this, but we're still gonna have to put this in an unsafe block because, well, setting mutating a static variable in Rust is actually an unsafe operation, so you have to put in an unsafe block. And now you can call that init function in our main, and this is going to work as we might expect. All right, so now we can now do everything else, and we say that if we run this, the static value should be my app as we might be expecting. So if you want to store a mutable static variable that does not have a constant constant creation, then you're gonna have to use an option to store it, or something like an enum, and then you can initialize it with something that is actually constant, like none, for example, and then you can initialize it like this. So another thing I wanted to show you, so I was talking about creating something like a counter, so I'm going to go back to that in a minute because it's something I wanted to show you. I32, I'm going to set that to 0 again. And now, so what I want to do is to print line counter. So I want to I'm just going to print out the counter variable, considering that it's considering that it's static. We're going to wrap it in the safe block. Now I'm going to do increments just like that, so that I can actually add 1 to the counter, and this is going to be in a safe block again. Okay, I'm going to say counter plus equals 1. All right, just like that. Or I don't know if there's counter plus plus in Rust. Yeah, there isn't, I guess, right? So we can do that. And now what I want to do is to increment and increment. So this is going to increment, and we should get 2 by the time we're done with this. Now this is actually cool, but I wanted to tell you about statics inside of a function. All right, so I'm going to move this static variable right here, just to show you what I'm trying to do. I'm going to move the static variable right here. I'm going to copy this function, and I'm going to make this function decrement, right? And I'm going to give this 30. This is going to start from 10, all right? And I'm going to make this function return something. So this function is going to return an I32, and this one is also going to return an I32. And so this is going to return counter, and this is also going to return counter. But this is going to, instead of plus equals 1, it's going to be minus equal 1. So what am I doing here? I'm creating an increment function that is going to have its own static variable, and it's going to increment and return that variable, and the decrement function that is going to own its own static variable. Remember, the variables are of the same name in this case, but these variables are going to be decremented, and then it's going to return the value right here. So what are we doing here? I'm going to say print line increments, decrement, and now decrement. And now running this program is going to, you're going to find that this actually is going to be 11 and this is going to be 29. And why is that? This is because every function actually owned their own static variables. All right, so these variables are static to this function right here, and these variables are actually, these variables are static to this function right here. And this is a very cool thing to have. So if you have like a program that actually has its own counter, a function can have its own counter, and then it can actually use that counter or store some kind of state that is going to be using to perform some kind of operation that it can then return back to the caller and continue with its operation like that. So this is a really useful feature in Rust, and I just wanted to show you guys. And I guess this video is already long enough. That will be the end of this video, and we'll see you guys in the next one. Make sure you like and subscribe, turn on the notifications, and I will see you guys in the next one. Bye bye.